I'm studying wave generations in the atmosphere. So waves are important for the atmospheric global circulation as they transport energy, momentum, moisture, or trace gases. My focus region is the tropics, where a special wave exists called the mixed Rossby gravity wave. Such waves influence the tropical weather, but also have remote effects, thereby affecting the weather in our region. In my research, I focus on how these waves can be generated by performing numerical simulations with a simple atmospheric model that is designed for studying wave dynamics. In general, it is not understood how these mixed Rossby gravity waves are generated in the tropical atmosphere. Current theories do not explain well their observed zonal scale, which is about 3 to 5,000 kilometers. We set up a new theory in which these waves are generated by interactions between tropical waves originating by tropical convection and jets. And the scale selection is dictated by the position of the jet. With this new theory, we explain the observed scales of the mixed Rossby gravity waves, not only in the upper troposphere, but also in the upper stratosphere. We set up this new theory by designing idealized numerical simulations with a simple atmospheric model that is called the Transient Inertia Gravity and Rossby Wave Dynamics, or shortly TIGER. The TIGER model is being developed in our research group, and it is a sophisticated tool to study wave dynamics in the atmosphere, as it offers direct diagnosis of the waves, and also we can isolate processes that produce these different kinds of waves. Such simple models are very important for fundamental research, as we have full control over the processes the model simulates, in contrast to complex weather prediction models where numerous processes are embedded, which would challenge the diagnosis of wave generations. There are practical implications of this research. For example, we know that weather prediction models produce errors, which are also present in the tropics and can be related to mixed Rossby gravity waves. With this new mechanism, we can determine the origin of the errors related to this special wave. So for instance, by looking at the zonal scale of these errors, one could speculate that they are coming from the incorrect representation of the background flow or the incorrect tropical convection. This research is part of my PhD studies within the Energy Transfers in the Atmosphere and Ocean Collaborative Research Center funded by the German Science Foundation. The highlights of my PhD is that I could design my own experiments with the TIGER model to set up new theories and to explain different features of the atmospheric circulation. In addition, I could present my results at international conferences where I had stimulating discussions and received a lot of great ideas. If you are interested in this work, check this link below.